basically the things that I'm going to talk about here, this is like a joint research between me and a friend of mine in Russia, Vladimir. Vladimir works for a big company where he manages to see like lots of traffic, not an ISP, but we get like a lot of visibility on Russian cybercrime, basically through the logs he captures. Plus, we get some traffic forwarded from Russia, and I'll explain it in a little bit why. But anyway, I roughly have like 3 sections in my presentation. The point of my presentation basically is to show like what the situation with cybercrime, like or like unlawful or like unethical internet activity is in like ex-Soviet Union area is as of like this year. Because like I'm frequently talking about stuff, so I'm trying not to cover the things that I've been talking about before. And we have a couple of projects running, basically systems that we're building. I'm still trying to graduate, basically. I'm a PhD student in university in Taiwan, so I need like interesting topics to write papers on. So we have like, we basically have 2 projects which we working on with the objective on eradicating like some of the problems that we're seeing. So, and I'll just walk through this project. If you've seen this morning talk by Paul Wixie, then this part would be like roughly related to what he was talking about, because we also do like DNS traffic analysis and stuff. And anyway, a brief like introduction, what's going on in Russia. Like to a certain extent, it spreads to the West as well, but there are certain limitations. It's like the reason why, for example, we're not seeing much of this kind of activity if we connect to the same site, like the same URLs, the same websites from Russia. A is because a lot of criminal activity happens through the binary networks, like advertisement networks, and binary networks, they're very focused. So we're not even being redirected to the malicious advertisers if we visit particular resources from like Taiwanese, Hong Kong, like Malaysian IP addresses. So what we do, we have like VPNs with endpoints in Russia, like proxies. So in order to collect some of the statistics, but still basically like botnets is like big thing. And in particular with like botnets, there was outbreak of like P2P like based algorithms for the botnets I think like a year ago. But what we're seeing a lot this year is basically like what is technically like a botnet? It's basically like a piece of software which somehow ends up on a bunch of computers. And this somehow could be like an exploit, or it could be a social engineering trick. And I'll show a couple of videos where you can see, where we'll see that like, that an exploitation of target system, like technically exploiting vulnerability is not the only means, and actually is not one of the most common ways of gaining the control. But basically, so you end up having like bunch of software instances running on those computers, and they basically call back. So in order to like, so the person who orchestrated the whole thing would be able to contact the machines. So the communication between the machine and the like so-called like CNC, command and control box, is like one of the essential components. So what's getting big this year is generative domain botnet control channels. And the research that we're doing is basically aiming at detecting that part of the infrastructure. And I'll show a bit more details in a bit. One of the reasons why like that kind of like crime is still, that kind of crime is still like very regionally based is not because it's more difficult to compromise machines in the US or like more difficult to compromise machines in Taiwan. And actually, like when you compromise machines as a part of the botnet, like that frequently still happens. But one of the reasons is because once you infect the machines, you need to the reason why people do this is like for money. And once you infect the machines, you have to like monetize it somehow. And the limitation is basically in monetization schemes. And within Russia, it's like way easier. Like if you have someone's phone number, it's way easier to make people to transfer money to you or like steal money by just either infecting the mobile phone or using other schemes that involve mobile phone. So like mobile phone is basically getting one of the main mediums of the fund transfer. But like drive-by download is like not the only like vector of like attacking people. Like what we've seen this year quite a bit is like more. It's not like I wouldn't call it like targeted email spam, but it's more like, for example, a website which is popular among accountants gets compromised, and then the database of the users within that website get dumped, and then this list of email addresses gets spammed with an exe file and content that is specific to the accountants. Like that would be like an accountant conference. So like we've seen this like outbreak, and basically once email gets executed, like the payload could be like what we've seen a month ago, basically there would be an executable that just starts running, looks for all the like PowerPoint, PDF, Word documents, uploads them to an FTP site. And this actually, like this attack scheme is very similar to what we've seen, I think, year and a half, like probably almost 2 years ago, when the similar thing was sent to like a bunch of US government official addresses with a congratulations. It was like around Christmas, so it was like, congratulations from Obama that you did like good work for the country. Please see this postcard and executable. So I think like the main problem was like users is like the users are dumb. Whatever you send them, if they reckon it's like legitimate, if it comes from like Obama or if it comes from a account and website, they're gonna run it. So I think the thing is like with all this like vulnerabilities and stuff, it's not even the point of fixing like technical flaws, because like the problem is like fixing the like mind of idiots. And yeah, people still download stuff. And basically the tendency that we see this year that like mobile platform is like becomes a lucrative target. We haven't seen much of the exploitation going on towards mobile phones. And when I say mobile phones, what we see this year is mostly Android platforms. And I think like there is a reason for this, because like it's more like open. It's easier to sneak application in. Google is doing some analysis on those applications, but we've seen paper, I think, by Charlie Miller as well. Like there are so many ways to basically bypass sandbox analysis of Android applications, and there are just like a bunch of like fake applications that once get installed on a mobile phone, either subscribe the user to a particular service, and I'll show you like one of the examples here, or just simply start like sending short messages to prime SMSs. Like this thing is like sort of getting deprecated, because like many platforms, they require like confirmation. What we've seen for like old versions of mobile phones, there would be like games which like get you in the mood of like clicking OK, like so you play the game, and as you start playing the game, they will start sending SMSs. But we don't see this kind of games this much on Android platforms, so that like there are other vectors. So this is like a screenshot from Black Hole 2 taken like maybe 2-3 days ago. So like this, I think, pretty fresh, just to give you visibility on what gets exploited in RUNET and how. So this is like a statistics from an exploit pack. And you can see that like IE browser is still like being most popular. So what we see here is like browsers, number of like browsers loaded on this exploit pack, number of like unique IP addresses, and once exploit is successful, it fetches an executable, and executable calls back like, yeah, I got executed. So this is like number of like successful callbacks. So you can see like that IE still is like holding the first place. There is like Firefox, there is Opera, there's Chrome, there's Safari. And what you will notice that like most of the browsers gets exploited, like regardless of the security features. But if you start looking at what exploits were used in attack, I think that's like pretty informative. That it's mostly like Java. And Oracle did a big favor, I think a month ago, when it took them quite a bit to fix publicly released vulnerability. So you can see like most of the stuff. And I think this like, Java is just like very convenient. It's like multi-platform, multi-browser, multi-whatever. Like there's still some PDF stuff happening, but like that's about it. And in terms of like platforms, you can see that like it's mostly Windows machines. So the main components that like, this is basically the crime. So the main components that people are having in order to orchestrate this kind of like malicious attacks, you'll see A is the CNC, or like the machine that usually it would be a CNC plus an exploit serving machine, and usually it's hosted on the same infrastructure. It would have different domain names because domain names get blacklisted, and then the domain name they would be using to connect to CNC would be typically different from the domain name that serves exploit pack, but typically it's the same infrastructure. So one of the things that we want to be able to find automatically or like semi-automatically is like where all these like CNCs are, and B, one of the like moving mechanisms of underground economy is actually traffic. So if people are not visiting those websites with the exploit packs, nothing happens. Botnets don't get built. They don't get infrastructure. They don't get stolen credentials. They don't get credit cards. They don't show stuff to users. Users don't pay money, and the whole economy doesn't work. So I think the key like working horse of the whole thing is traffic. So you will see that a lot of online abuse, like from the spam to like search engine optimization, like black and white, happens with the single point of getting traffic to particular websites. And one of the like very common things is like how many people in this room run WordPress blog? 1, 2. Well, apparently not so popular. But if you take an average user who wants to be known through the internet, like I think it's like 90% of them they would probably be running WordPress just because like it's like one of the default options when you buy hosting. B, just so easy to run, and it's one of the like most compromised applications. So what's basically happening is those websites like WordPress, OS Commerce, OpenX. OpenX is actually a particularly interesting thing because it's OpenX is if you want to run your own like mini binary serving network within your website, you will run like OpenX server, and then you can interconnect with other binary networks. But the thing is, OpenX used to have like so many bad vulnerabilities where you can have admin control of the thing, and then once you have control over the database, you can basically start injecting malicious scripts into the thing. B, you can compromise the OpenX server itself, and that's what we've seen as well. And either you like load an Apache model, which like this thing gets like very difficult to find because no files on the file system get changed except for like an additional Apache model is being loaded into Apache web server, and every time the text script is being served, it's being served with appending JavaScript that redirects stuff to the infrastructure. And when I'm talking about infrastructure, it will not be necessary an exploit pack right away because in reality, like the situation is like a bit more complicated. The people who are paid to bring traffic to particular sources, they pay to bring traffic to TDS, traffic distribution systems. And people who build botnets, they buying stuff from the TDS. But anyway, so basically, compromised machines is one of the like key components in bringing traffic. So we want to be able to rapidly, quickly, at large scale, identify which machines could be compromised, like maybe in a scriptable way. And that's also like one of the prerequisites for like in one of the projects which I'll be showing here. Binary networks, like I think that's like very difficult to deal with. Starting from the point, the binary like advertisement network itself is very complicated and it's very dynamic. So the way an ad is being rendered depends on your IP address, on your could depend on your cookie, on your time zone, which is disclosed by web browser headers. And even if you load the same URL twice, it's like you cannot enter the same river twice. Like the thing always moves. And because there's like this dynamic bidding, it's very difficult basically to trace malicious content in binary networks. And I'll be showing one of the videos in my examples where we can see one of the things like binary network, like malicious binary network in action. And another thing is what the tendency that we see happening in Russia, that there are certain binary networks like advertisement agencies, which like on the legal side, they're actually taking offers for advertisements and they're looking for publishers to place their banners. But the sole purpose of those companies to exist is to distribute malware. And the way they do, the whole thing would be happening like on the first render of the page, you will be served an exploit pack or a variation of exploit pack. And all the consequential renders of the same page, like based on the cookie, you will be served a regular like advertisement content. And what is like getting difficult here? It's like a legitimate company, but the thing is they're distributing malware. But if you basically start trying to prosecute them, it's not worth the effort, because like there were like certain cases when they just say, oh, our machines were compromised, and there is like no proof that the redirection to the exploit pack had actually any links with this company, with the exception of statistics. So when we run a sandbox like 100 times in a row with a like fresh environment with the fresh IP, we get malware served every time. But other than this, and this has been going on for like a year, but other than this kind of like statistics, there is no like obvious proof, and like this kind of statistical proof doesn't work well in court. And that's also like the reason why those companies exist. So what I've been doing like before, we were like building like a behavior-based analysis platform for malware. So I've been looking into this thing for maybe like a couple of years by now. But what's getting different like this year is those guys, they spend a lot of effort on preventing automated detection. And the point when it gets difficult is when malicious behavior only exhibits itself in like behavior analysis model only when there is a human interaction. Like this is like one of the simple examples that we've seen. There would be like a JavaScript, but the redirection would only happen when there is like a mouse movement. And this kind of thing, like if you know that like they're doing this kind of stuff, this kind of thing is like really easy to simulate in botnet. You can just like simulate the mouse movement, but like their creativity doesn't stop here. One of the things that you will frequently see is like a pop-up banner done with like just JavaScript and CSS, where you say like click here. And if you don't have like OCR recognition system that would recognize that like user is motivated to click here, then you will not be able to make the like particular website to exhibit malicious behavior. And how like most of the like internet monitoring systems are working, like, well, we did it at my previous company, but I know like other companies which like they do it basically the same way. You basically have like a sandbox farm that continuously crawls like internet, renders it in real browser, and then you like have patterns detecting malicious behavior. But like this kind of thing doesn't like always work. So in this case, I think the best option is to have some sort of like monitoring module in the browser which would notify headquarters whenever like whenever a malicious behavior was detected. But then you have to make users to agree to install that kind of stuff and so on. But like another thing that we see like a lot of this year, like the monetization scheme there used to be like prime SMSs like used a lot years before, but like as of this year, like you don't see this kind of stuff that much. But subscription to a content is like one of the big things, and I'll be showing in a video that like there are so many like social engineering tricks which are being used to get people to subscribe to particular content. Other thing, and I'll show this thing on a video as well, is like just very direct. Your computer has been locked. Here is the phone number. Send me like 1,000 rubles. I'll send you unlock code. You'll be able to use this, and I'll show you in a moment. But the thing is, in Russia, in order to have like a mobile phone, the only thing that you need is a copy of a passport, which is also available for like $5 per copy, and in one hand. So like technically, if you want to have absolutely anonymous phone number, like that's very possible. And then what you do, you have like a phone number, you make people like sending you money, and periodically you go to a telco and you can say, I don't want this number anymore, I want cash. Or you can like transfer your balance to other number and like convert to cash. But there are ways of converting your phone number balance into cash. Another thing that we see as well, like this thing was taken directly from an Android application where there is a callback gateway where they get the numbers to start SMS, where they get the numbers to send SMSs to, but that's like one of the things that we see as well. Like mobile scams, like mostly like fake applications. I think this year, like it's a big one. There's like one of the examples, like Opera Mini, which is it used to be like on upmarket as well. You can also download it directly from like this particular website, like Samsung 325RU, which is supposed to be an application distribution website for Samsung like mobile phones. But if you start looking into the code, like like one thing which we'll notice like is most of the Java code is like obfuscated. Like if you see like we decompiled the stuff, and if you see like most of the classes, they basically being loaded dynamically. So doing like static analysis on this kind of applications, I would say would be very difficult. Another thing that we've seen on Android applications is basically there's like multi-stage load. So the application that gets loaded through the app market right away is clean application which doesn't have any malicious function, with the exception for that it allows user to install updates. And the malicious payload would be like within the update. And the thing is like with this kind of model, it would be like so difficult if you do like behavior analysis, because you'll have to be able to simulate real user using the application in order to trigger the update mechanism. And then, yeah, it gets difficult. But then another thing which is interesting is actually how the monetization thing is happening here. So basically, in Russia, like there is a way to become a content provider. So anyone can become a content provider. If I have particular content, I can go to telecom, I get an ID and a document for the API, and the way it works, through this API, I send a mobile phone number to the telecom. And I can also specify like the content of the SMS which will get sent to the this mobile phone owner. And then the telecom will send a confirmation code to this mobile phone owner. So as soon as the mobile phone owner provides me with the confirmation code number, through the API, I can send this confirmation code to the telecom. And if the confirmation code is correct, I can subscribe user on content, which technically means I can bill this user, like in this particular case, it's like 300 rubles, which is like 30 ringgit per month, on unlimited period of time. So unless user discovers that he's been subscribed to the content and unsubscribes, like I'll be like milking him. And this kind of abuse is like very widespread. Telecoms, I think telecoms in this situation, they sort of like on both sides. On one side, they like supposed to be protecting their users, but on the other side, more users pay, more money telecoms get. So they make like they have in order to show user that they actually, like good guys, they have a requirement in the API specification that whenever someone installs an application which subscribes user to the content, there should be a statement saying that you will be billed and the amount of money. And actually, like in this particular application, there is a statement. If you look into the application through Android phone, it has like some HTML content that it shows to the user, and it just what it basically says that there will be application installed. But if you start looking into HTML code, there is actually a notice saying that it's paid for content, and that's how much you're going to be billed. And what you will notice here is that this content is being displayed with a style none, so it's not being shown when the application is actually being installed, and that is how like the malicious applications find this balance. So on one hand, they actually provide this information. On the other hand, the user who installed the application doesn't see it. But the requirement is by the telecom is that there should be the statement. The requirement doesn't say that it should be visible to the end user. And there are like lots of stuff like this. So I think like I prepared a couple of videos. Last week I traveled to Russia, so we just recorded like, we did a few experiments. So one thing which we did, we went to the Yandex office, and Yandex is basically a Russian Google sort of thing. It's like biggest search engine. They do malware analysis. Basically whatever Google does, Yandex does as well. They also have Google Maps. So we did a couple of experiments. We had a list of binary networks which we know that they serve malicious content. And we were running like our sandbox environment through the Yandex network, see if we would get infected. And under like 99% of like occasions, we would not be served any malicious content. And there is a reason for this. And the reason is that all the Yandex IP addresses there was in the blacklist. I'll probably start the videos so we can. Yeah, no, I'm not very good with mouse. Sorry. So basically, but there are also other things that like you will notice that the guys are like the steps the guys are taking in order to prevent automated analysis. So one of the things is we know there is a particular URL, and it loads malicious content through the binary network. One of the things that we noticed, just take that URL and you type it directly into the browser, you will not be served malware. Yeah, I think it's dead again. Oops. Yeah, but so basically you have to find that website through a search engine, and that's what we gonna do here. So I'll start the video, and also like. Okay. Oops. Okay, look. So basically, pay attention on the process list here. So you'll see like one. Yeah, I'll probably go back so because I think we skipped some of the video thing. Oops. Hold on. security. So basically, pay attention on this thing. So this is like list of the processes. We just start like the proxy and like the process monitor, so you can see what's happening. And what this website is basically online like medicine trading like website. So here we loaded it in search engine. Like we use Yandex here because like that's a Russian search engine, but like pretty much Yandex, Google, being like any search engine, as soon as the search engine is in refer, the malicious content will be served. And what will happen here, like we basically just click on like online medicine website. So the click happen and start paying attention on the process list. Oops. So what we see here, obviously like this is also like a black hole exploit pack. It launches the Java exploit, so you can see Java is being loaded. Applet is being executed. The good thing about this particular Java vulnerability that it's very reliable, because there is like, and there is no impact on the VM. And what you will see at this point, so at this point this guy is already compromised, so you can see the executable being started. And in this particular, like the type of, basically people who run exploit packs and people who own the executables, usually like two different groups of people. So, and the way it works, the service, people who write these executables, they actually buy service from the like exploit pack owners, and actually exploit pack itself is also like paid for service. So you can basically say, I want to distribute this binary through this exploit pack and through this TDS traffic. And like this particular website either is compromised or uses binary network that sells traffic to TDS. So once the binary is being executed, this guy basically like continues shopping, but there is particular delay here before his machine gets locked, and I was showing it in a slide as well. Yeah, so let's get to the delay thing. So like technically nothing happens because like the guy is basically just like continues browsing, and there is just a particular sleep time before the machine gets locked. So what happens at this point, the machine gets locked, and in order to get the unlock code, you have to like do the balance transfer to this phone number. That's the thing which I was showing. And the probability of like catching this is like extremely high, because like the keywords that we were using for the search engine is just online like shop for medicine, like one of the like popular keywords. And like this is just like an example of website. There are like a bunch of them, because what the thing here is that the content is not being served through this website. The content is being served through the binary network that uses this website as an advertisement platform. And I'll show another example where they actually had, because we were running the whole thing on VirtualBox in this example, and just another popular online library. Also, like this kind of content, if you, like we did experiments, we rendered it through like Hong Kong, Taiwan IP addresses, you're not being served the malicious content. And that's also the reason why like in Yandex, or in Google, or in Bing, you will not see this content being marked as like malicious, because they limit distribution, like the target distribution, only to the IP addresses which they believe they can cache on. And also, there would be only particular time of the day. So for example, in Russia, people start surfing web during the lunch break, when they can go online and start reading news. And So this binary network, which let's get to the website. So we basically get to the library, and there is like they call like teaser top. It's a binary network which will display advertisements here. So the teaser top binary network, like technically, we believe that the sole purpose of setting up this advertisement company or the binary network is to distribute malware. But the reason why they still can pretend to, like, as they are running legitimate business is because A, malicious content only served once per IP per cookie. B, the malicious content is only served during particular time of the day. So either like nighttime when they believe like Yandex people are sleeping, or the rest of the world is not relevant because they only distribute the content to particular IP addresses. And B, lunchtime. So, and what you will see here is like very similar thing. It's also like Java exploit. You can see the like Java executable was started. Then the whole process of dropping an executable actually happens in 2 steps. So the Java exploit will fetch the loader. The purpose of the loader is to be able to execute on multiple number of platforms. So Windows XP, Windows 2K, Windows 8, and then the loader will fetch the actual payload with a useful content. And in this particular case, the actual binary had, you can see there is a binary started here. The binary had virtualization detection, so it executed like an opcode which under VirtualBox generated crash. And this is basically the whole thing, just like to prevent automated analysis. But another thing which I want to show here is, even though this thing is obviously malicious, because it was served through this website, automatically executed on our machine, started. If we like do the antivirus scan for the thing, I'll probably just skip directly to the antivirus screen. So basically what we do here, we went to VirusTotal right away, got the binary, uploaded to VirusTotal website. And you can see like, right now we like, there is a scan happening, it takes some time. And you can see that the detection rate of the binary like was 0 out of 41 antivirus engine. And that's basically the reality of the cybercrime thing happening in Russia. Like most of the antiviruses that like people have installed on their computers, they're like technically useless. Another thing which I want to show in I think I'm overspending my time on this thing instead of my slides, but like I'll just briefly show another video on the monetization thing. And this thing, like, we basically just recorded like yesterday. It's still pretty active. It's the same thing. You go to like a website, you find it through the search engine. But in this case, they not bother like trying to install any binary on you. What we will see here is, I'll just skip directly to the content, I think. So one thing, like, there is an offer to download update. An offer to download update for Mozilla browser, and that's like the whole thing is obviously fake. But how this thing gets monetized? Once there is an offer to like download an update, you start the whole like download process is simulated with JavaScript in the browser, and then there is a pop-up window. In order to like complete the update, please give us the phone number and confirmation code. And what will happen in this case is there is no malicious payload, there is no executable. It just, the whole thing is just like pure social engineering. So what will happen in this case, you enter the phone number, SMS will get sent to this number. The user enters the subscription code, and like there are 2 variations. Like you can see, one is like the update, another one is antivirus thing. But basically the mechanism is the same. You enter the code, you get subscribed to to the content. So that's basically like a few the common trends that you will see was the cybercrime in Russia. And I'll just go back to my slides and I'll show you what else we're doing with this stuff. So what we're basically trying to build here is 2 projects. One is we're trying to automate detection of the CNC once machines get infected. And another thing that we do, we're trying to automate detection of weak targets and have some automated notification mechanism for the weak target owners before machines get compromised. So basically, we're trying to A, kill the infrastructure, and B, kill the weak, vulnerable targets for them. So one of the things that we do is we do CNC identification through the DNS traffic analysis. This morning there was a talk on passive DNS. If you were at the talk, you probably know what passive DNS is. If not, in short, we have an ISP that sends every DNS packet that travels through the resolver. They send a copy of the packet to us, and we do processing of that stuff. So our input is basically DNS packets. One thing which technically you don't have to actually have your own DNS collectors. With IC.org, you can get access to the raw traffic. But one thing which you will be missing there is, in order to do the botnet correlation, you also want to see IP addresses of the machines which looked up this particular domains, in addition to what domains they looked up, what was the result of the lookup, and so on. And I see they have this privacy policy, so they're not giving away the IP addresses of the machines which were looking up the domain names. And that's one of the reasons why we decided to build our own passive DNS thing. And with the spike of generative domains, that's one of the common ways for the botnets to call back and find the control center, but that's not the only one. I don't know, can anyone recognize what's on this screen? I don't know. It's like a Twitter-like social network, very popular in Asia Pacific. But that's another way, we've seen this year as well. Basically, there are encoded posts on Twitter-like thing, which is basically a reference to CNC IP address. But we're not looking into this thing. So if you start looking at the raw traffic, the raw traffic will look like this. So you will have a bunch of DNS queries with responses which either would be non-existent domain, which ercode 2 on a DNS spec, or name server failed, which would be 3. And then only few of the domains within the similar group would return, successfully return IP address. And our detection mechanism is basically based on this principle. So A, we're trying to identify this kind of noise and group by the domain similarity from the whole DNS traffic. B, we're trying to identify, A, once we identify the group, the cluster. B, we're trying to identify IP addresses, which might appear, so we have links to the infrastructure. And since we have our own passive DNS database, we can do back and forth lookup, and we can see, so for this IP address, what were the domain names you've seen a week ago, or so far, for whichever pointed to this IP address. And then we can basically start recursive mining of the infrastructure this way. And I'll just show a couple of screenshots. One of the botnets which was popular this year, September, August, Carburp. Typical distribution is drive-by. I have diagram in my slide, but I think it's very common for the stuff that I was showing on the videos. That's basically one of the similar examples. And I'll just skip directly to the detection. So roughly what our architecture looks like, we have an ISP in Russia, which agreed to send us all their DNS traffic, we have a collector. At the collector point, we do some filtering, because one of the things which you will notice when you get lots of DNS traffic, there's a lot of failed, because we are interested mainly, like, the starting point is failed queries. But there's a lot of failed queries for, like, in other RP lookups, like reverse lookups. There are also lots of, like, failed queries for some hard-coded domain names for, like, either particular software vendors, or like Chrome uses randomly generated domain names. And on the collector point, we're basically doing this filtering so we can minimize the load on the rest of the infrastructure. The rest of the infrastructure is basically built on 3 machines, so it's like, it's not like big data sort of thing analysis, but, and we cluster, we index data by epoch. So we have a definition that, like, for example, our epoch is like 2-3 days, and then we switch to a new Redis file. And then we also do historical indexing, so we can have queries like, so show me which domain names ever were pointing to this particular IP address. And like that kind of stuff is being done in Analyzer. So when we do indexing for real-time epoch indexing, we use Redis. For historical records, we use Lucene. And Lucene is basically running as a like cluster. So we have like several Solar nodes, and we share the data between them. And Analyzer basically is capable of doing requests into both things. Another thing that we are capable of, that we have in our system is lazy whois lookup. Because one of the things which we noticed this year, by mining patterns through whois data, you can, there are basically ways of like signatures that you can apply to identify potentially malicious domain names even before they're being used. So like one of the typical things that we notice that domain registration would be typically 1 year. Only particular registers are often being used by botnet masters. So we have like this set of signatures that we map to the whois. There is also a problem with with querying whois data. Because it's human readable text. So in order, it's very difficult to do automated parsing. So we just have like regular expressions for whois data. Another problem with whois data is, like for DNS traffic, we just collect passively. So there is no limitation on the volume. But with the whois data, the biggest problem is if you do bulk lookup on the whois, you just get blocked. So the solution that we have so far, we have like round robin whois proxy, so we can balance our like whois lookups for different machines. And B, our whois lookup is like lazy. We've done it in the lazy form. So what we do is, if we want a domain, we throw it into whois lookup component. The whois lookup component controls the threshold of how many whois requests per second we can do without being blocked. And then we fetch the whois information and we put it into Redis component as well. And one of the things was one of the reasons why we believe it's necessary if you do like real-time malware malicious domain analysis is to fetch whois information, because the behavior that we noticed this year, and I'll have some data on this, is some of the whois data is live only for like 30 minutes. And the reason for this, for the bad guy, that's very like handy feature, because like the domain exists on the internet space for 30 minutes. Once the domain is off, it disappears from the internet. So if you didn't catch it at the moment when the domain was in use, you don't have any information. You don't even know which register the domain was registered through. You don't have any leads to the actual identity. So I'll just show like a quick walkthrough. Like this whole process is automated, but if you were doing it step by step, you can just directly connect to our like Redis indexer, and you query the domain names which have a similar distribution within the epoch. So, and you will notice that like there is particular group of domains with particular pattern and very similar distribution here. And in this case, we have domains which where name servers are failed, which means like most of these domain names were registered at one point of time, so they were already used by malware, and either they got sync hold or disabled or like abuse complaint was filled in. But the more interesting thing is you can also get the distribution for the domain names which are non-existent. And the reason why I think like this is a very useful bit of information is if you want to take over the botnet, all you have to do is you take like 11 USD, go to like the cheapest register available, register this domain name, install the CNC software on the machine, and the bots start connecting to you. And like that's like super cheap, legal, and effortless. So anyway, like once you get the pattern of like either like non-existent domains or failed domains, what we do, as DNS packets come in, once we've done all this filtering, we try to cluster them by similarity. So once we index the cluster domain names, we have like groups of domains which we can start looking up by cluster number. Like, so I want to see the domain name group which matches this group. So and in Redis we basically break it into like 3 fields. So we have domain name, cluster ID, and error code. So we can like look up things quickly. So then we pick up like the cluster that like cluster ID that we believe might belong to the botnet, and we get the whole list of the matching the domains, including the domains which either like failed, existed, and current. And out of this like big list, you actually get to see certain DNS packets which at the moment when you were monitoring, which were successful and return IP addresses. So, and that's what I'm showing here. And from this point, you can actually start doing recursive lookup for the whole thing. And what we noticed is, even though like domain names were fresh, some of the domain names were not registered, some domain names were failed, but if you Google for these domain names, you'll find nothing. They're not in any trackers. But if you start looking by IP addresses, which the infrastructure belongs to, you will see either autonomous system, or in this particular case, you will see that IP address directly was registered on multiple trackers. I think this is like from Semantic, this is from the Paleo tracker, and the same IP address. So like the IP addresses, as you see, which host infrastructure, they don't change much, but like the domain names fluctuate a lot. And from this point, because we are able to provide the list of the domain names which might potentially be used by attacker, we can generate like on-the-fly signatures for the traffic monitoring, and we can, like once domain lookup is successful, there would be lots of like HTTP requests to these URLs, which is basically callback to the CNC thing. And another thing which comes handy when you do this kind of like recursive lookup, you start with like picking up randomly generate domain names based on similarity and the noise that they create in DNS traffic. But you can also find that at one point of time there were like some domains which look very legitimate. For example, stolovka.us, that's like just a Russian word. And there is no way, if you were just like analyzing domains like this, there is no way you would pick this one up. Or like leadbrandcloses.net, or like Dima LTD, which we're showing here. And then you can see one of the interesting things that like from our like passive DNS, you can see the lifetime for each particular domain is only like up to 5 minutes. So domains have very short lifespan, and unless you like are able to do like real-time detection, there is no way you can do like if you pick it up from the logs and start like writing your like firewall blocking logs in the evening, by that time domain is not in use anymore. And that's also the reason why we have so many failed name server failed lookup. So once domains were disposed, there are 2 ways. A, I will show you like the whois trick that domain just disappears, and B, the name servers would be pointing to like loopback, or in case if the domain was sinkhole, it would be pointing to like configure sinkhole IP address and so on. So once you do the automation, we're actually able to do like, this is basically the graph that we drew from the output from like our automation script. And if you zoom in, that's basically how like each of the interesting clusters would look like. So you'll have like a bunch of domain names which are like basically pointing to more or less either the same IP address, or it could be the IP address with the same C-class subnet. And that's like in our detection scripts, we can like have all this like balls that we can tune whether we want to be fixed to a particular IP address, because it's still like try and error sort of thing. In some cases, for for some IP ranges, the whole C class could be malicious, and we, in a script we tune that we want to look up for all the domain names that point to the same C class. In some cases, it would be a single IP, as we see on this screenshot. So another thing that we like when we are playing around, Russian business network apparently still active, like because the traffic that we get, we start collecting traffic from last year until now. So and we still see the IP addresses. Like if you look into URL query, there's a reference to it that belongs to like that was logged as a RBN. In terms of load, like for it's a small, well, a medium city ISP in Russia. So and in terms of load, we only get like around 2,000 packets per second, like not that much. So the initial collector, we only have like 32 gigs of RAM, and we're able to like handle it there. So this is like roughly like how much packets per day we receive. The amount of the like malicious domains, so it's roughly like, well, not really 1/3, like less than that. But the thing is, since it's like generated domains, we can see actually the tendency of like recurring lookups. So for each of particular domains, there would be up to like 100 lookups like recurrently. So if you want to mine like unique domains per minute, like that's the average we get. And how can you use like this data? Obvious, like you can runtime generate blocklists that you can block on firewalls. Yeah, I think I'm running out of time, so I want to finish this. Another thing, you can like start doing like botnet sinkholing, taking over the botnets, like other stuff as well. This is like one of the interesting things. Like first, I'll ask you a question, then maybe I'll explain. One of the things which we started like noticing this year is there is a number of domains which also used as a CNC for the botnets, and the way they look like is just basically concatenated words. But what's special about these domains is not like even the zone where they're registered, but if the domain is currently being in use, so you actually see it right now in DNS traffic, you look it up, you get the DNS data. But if you start looking up like an hour after the domain name is like not appearing in DNS traffic anymore, you just get domain like who is not found. How is this possible? Like, because for us, initially we didn't have like a clear answer to this. Later we talked to one of the registrars, and he pointed us to one of the like possible ways. But like we believe probably like one of the registrars was compromised. But another thing that like one of the registrars attract our attention on is that you can actually have like, as you buy shoes in the shop, right? So you can take the shoes, you can try them on. If you're not happy within like 7 days, you can return the shoes. The same thing you can actually do with domain names. And that's what, I think that's the feature the guys figured out with particular registers. So you can take the domain on trial, you can use it for 30 minutes, and then you can cancel the order. And once you cancel the order, the information, like one of the things like how to pick up domains on trial is the domain name will be like in whose output, it would be in add period, which means the domain was just purchased. And then within the trial period of time, they can return the domain like automatically with the script. This whole thing is done like with a script, because like within a day there could be like over 300 domain names, and I don't think it's possible to like do the whole thing manually. You can cancel the transaction. It's going to cost you roughly like if the domain name costs like $11, you will be still charged like roughly $1. But for $1, you get disposable domain name, which leaves no trace on the internet. So if you didn't catch this thing when domain was active, there is nothing. So this is basically on the DNS-based detection. Another thing that we do, we also do like proactive network scanning per region, very similar to what Adam was showing last year. Basically scanning particular ranges of IP addresses for services and software running on these machines and indexing this. We like also use Solar for this thing. And realistically, like you can scan the whole internet like this, like some statistics from a paper within like 100 days. So it's technically possible to have a database that within 100 days each can index like services on the whole internet. For us, we're not interested in the internet per se, but we are more interested in geographically focused IP ranges, like we scan Taiwan, we scan China. We store all the data in Solar database, and one of the things, like the items that which we're interested is ASN, who is the owner of the network or the IP address, which country it belongs to. We use geo-IP location right now, which is not very precise, but we also look up geo-IP location of particular IP address, and we do some application fingerprinting. So if there is a web, we use some web application fingerprinting tools, so we can basically fire queries saying, I want to see all the people running OS commerce of particular version within type A city. And like with this kind of like database, like that's very possible. That's like roughly our architecture. Like we have a UI, but we don't really use it. UI is just if you want to see if your data is in it. But basically, you can, we have also API that we can script in, RESTful API where we can query IP addresses by any combination of like software regex or like software binary regex and geographical location and ASN, and this happens like immediately. So if you want to know like people running vulnerable version of Belok within type A city, like it's like really like less than a second you have the list of the IP addresses, and then this whole thing you can basically, like one of the uses, like you can automate your script of like once a new vuln is being announced for like particular web application, you can automate your script that will just fetch all the people running this particular version of vulnerable thing and send automated warning messages. But there's like a lot of other things. If you're doing pen testing, you can say, show me all the vulnerable OS commerce installations that belong to Malaysian Telecom, and it's like a second query. So yeah, I think I'm roughly out of time, so I don't know if you have time for questions, but if you do, yeah, I'd like to have some.
We can extend it. We've got a coffee break right now. If you got questions, we can do it during the coffee break. But I do have to say we are starting at 4 o'clock with the next presentation. So.
Or if you brought like rotten tomatoes, shoes, you can start throwing them as well.
Any questions?
Any tomatoes?
So you don't have questions, so we can have coffee.
All right, well, there is my email address. So if you have questions later, that's how to find me. Thanks.
Thank you very much, Fyodor.